In this question, the daily time spent on homework is denoted by X hours. And then they say that it's follow a normal distribution with mean and also standard deviation like this, which means that X follow a normal distribution with mean and standard deviation square. They give us some sample, which is 40 students data, and we are going to find the 90% confidence interval for mu. We need a starting point to set up the confidence interval, and then in our practice we are going to use the sample mean to be the middle point of our confidence interval. So we are going to interpret this data. They just give us the number of each class. That's why we are going to use the class mark. The midpoint between 0.5 and 1 is 0.75. That means 0.75 appear 11 times. Similar reason, 1.25 appear 13 times. Then we use our calculator to get the sample mean. It's 1.45 hours. And we have to know more about the sample mean distribution. This is the original random variable distribution. When the sample size equal to 40, then the sample mean will follow another normal distribution with the same mean, and the variance will become the original variance divided by the sample size. That means the SD for x bar is equal to 0.4 divided by square root 40. We have the starting point, which is the sample mean in this data, and also we have the standard deviation divided from the original deviation. Now we can construct the 90% confidence interval. For mu, it should be from our starting point 1.45 minus something, 1.45 plus something, and 90% confidence interval, which implies that we use our corresponding upper limit and the lower limit to ensure that there is 90% of data covered within this range. Therefore, if we just look at half of it from the standard normal distribution table, we are searching for the area equal to 0.45. We search 0.45 here, and then we find that it is a value exactly in the middle between these two values. Therefore, the corresponding standard score should be between 1.64 and 1.65. That's why we take 1.645 times of the SD of sample mean. So SD of sample mean is 0.4 divided by square root 40. Similar reason, right hand side 1.645 times of our sample mean standard score is approximately 1.3460 to 1.5540, correct to nearest 4dp. In part B, they are asking for another confidence interval, which is 97% confidence interval for mu, and we want to find out the least sample size to ensure that the width is at most 0.3. So we are going to use the same logic. First, we need to know about the sample mean. Therefore, we are talking about when the sample size equal to n is no longer 40 is our value that we need to find out. Then the sample mean will follow another normal distribution with mu, and the variance of the sample mean is the original variance divided by n. After that, we need the corresponding standard score for 97% here. We use the same logic. The red area should cover 97%, which means that just half of it should cover 0.97 divided by 2. That means 0.485 area. We are going to search this area in our table once again. 0.485 is this point. That means the corresponding standard score is 2.17. So the upper limit for the confidence interval should be the mean, and then we plus 2.17 times of the standard score. And then we are concerning about the width here. So the width at most 0.3, that means smaller or equal to 0.3. And then the width is talking about two sides, left hand side, right hand side. So we have 2 times of corresponding standard score of the sample mean standard deviation. The corresponding standard score we already calculate is 2.17. And the standard score of the sample mean when the size is n is 0.4 divided by square root n. We have this inequality. Both sides times square root n, because square root n is larger than 0, so no need to change. Since square root n is larger than 0, this range do not cover 0, that's why we can take square on both sides without changing the relation. So n is larger or equal to 33.4855. Given that n is integer, so the least value of n is 34. Then we already get 7 marks here. B1 is a very simple normal distribution questions. Now, updated information. We know the mean is exactly 1.48 and the variance is 0.4 square. The required probability is the probability that the student has to attain the homework guidance class. The criteria is the corresponding student spend more than 2 hours a day. So we are talking about when x, that means the time, is more than 2. That's typical, and then we just need to standardize it. We express in terms of standard score. 2 minus standard score 1.48 and then divided by our standard score 0.4 here. We are finding the probability that when the standard score is exceeds 1.3. By using a graph in terms of standard score, the mean had the standard score 0. We have a limit 1.3 standard score. We are interested in this area when the standard score existing 1.3, but from our table we can get this area only. That's why to get our target, the blue region, we have to use 0.5 and then we subtract the red region here. It's equal to 0.5 minus the probability that set between 0 and 1.3 from the table. When the standard score is 1.3, then the area is 0.4032, which means that the table tells you this area is 0.4032. Then we find our target probability is 0.0968. So we have the answer for the following part now. Then they say that there is a sample of 15 students now randomly drawn from the school, and they are examined one by one. Given that more than one student in the sample have to attain the homework guardian class, we have to find the probability that the 10th student is second student who attend the homework guardians class. So it looks so complicated and confusing. That's why we should express it in terms of mathematical expression. This question they ask for a conditional probability that given the situation is more than one student have to attain the guardian's class. So, in mathematical expression, I better let a random variable for the number of students need to attain the homework guardian class. We let y be that random variable, and then we know that y follow a binomial distribution. We repeat the same thing for 15 times, and then the successful rate, that means the guardian's class probability, is 0.0968 here. What we need is given that more than one student. Beware the wording more than one, that means we don't accept 1. We are talking about y is larger than 1. We're counting from 2, 3, something like that. Under this situation, we are going to find the probability that the 10th student is the second student who need to attend. Now it's give a clear idea what we are going to do. First, we need a denominator which ensure the given condition. Next, we are going to consider the n case of these two events. And the first event, the second student, imply that the number of students who need to attend must be larger than 1. So this part is meaningless. The key point is just this part. Then we are going to calculate them part by part. Just the given condition first, y larger than 1. They mean among all outcomes 0, 1, 2, 3, 4, so on and so on. We don't accept 0, we don't accept 1, and we start accepting from 2. So it's equal to 1 minus the two cases. In your exam, make sure you list out the outcome like this and then exclude the unwanted one. Avoid any careless mistake. So we have 1 minus fail for 15 times in a row. So 1 minus 0.0968. It's not necessary to let A be this time because it's relatively simple. And then minus among 15 we have 1 time. We success for 1 time. And then we fail for 14 times. We get 0.433757063. And then we focus on the numerator. It's a typical hypergeometric distribution. Before the 10th one, we have 9. Among that 9, we only accept 1 student who attend the guardian class. So, among the first 9, 1 of them success. And then another 8 of them fail. And finally, the last one need to success to end this case. So we have 0.0968 at the back. Is equal to 0.0373477768. We get all the components, then we just answer it by our decision before. Divided by a given condition probability. We get 0.08610292. So, if you listen to this explanation, it's look quite easy, and then it's because I'm willing to write more things to clear my mind. So, therefore, you should write like this at least in your draft paper, and then you tidy up your answer to present better. Don't just follow the marking scheme.